I'm going to talk a little bit now about computational social science and what it is, and again, kind of how you can learn more about it and get more resources to learn about it. If you want to go, I think knowledge mobilization might be the second session that Allison is doing. You're welcome to note. I won't have my feelings hurt if you decide that that's a better fit, but I'm happy to have you stay here as well. So computational social science is kind of, broadly speaking, the application of a range of methods and tools that come from primarily computer science and other natural sciences like physics, math and stats, even environmental science, that we are now increasingly using in the social sciences to understand kind of social behaviors, social phenomena, usually with larger data sets or big data. So some of the things or kind of keywords that you'll hear coming up with, or in the context of computational social science, are big data, machine learning, artificial intelligence. Those are all kind of considered parts of different aspects of computational social science. And I would say its closest analog in the humanities is the digital humanities movement. And in fact, the Sherman Center for Digital Scholarship, really here at McMaster, I see as kind of the humanities version of Spark, because they're trying to help support researchers interested in digital humanities in the way that we're interested in supporting researchers who want to innovate and adapt and adopt and use new methods in the social sciences. So in the last decade, computational social science has really grown quite rapidly. And this is largely, again, due to kind of these changes that we all have these devices in our pockets that, track us as we're walking around, that are generating large amounts of data. We also now have these very, very powerful laptops and desktops and cloud computing that allows us to kind of process huge amounts of data. And so there's really been a rapid increase in the number of publications in academia that are using these types of methods and data in the last decade. And so this comes from a special issue of Nature, the journal Nature, this summer, that focused all on computational social science, to just give you a sense of how it's growing. And in particular, computational social science, or the interest of social scientists in computational methods, is also really growing. And one of the challenges, though, is that many of us got into the social sciences primarily because we were interested in social questions and social problems and issues. And, we're not computer scientists. Maybe we don't even know where files get stored on our hard drive. And now there are these new tools and these new ideas and new opportunities that can open up the possibility of answering a whole range of questions that weren't possible to be answered before. So what types of data are used usually in computational social science? So the types of things, and this is certainly not exhaustive, but social media posts and networks. Also, all the trace data that are unintentionally created by users. So website navigation, interactions with apps and visits on websites, the ways that our mobile phone moves. You might have seen, researchers have used kind of Google mobility trend data to analyze compliance with COVID restrictions and protocols, because Google has a lot of information about where we're going with our phones in our pockets and when we use Google Maps. We also have a lot of data about our entertainment habits, what types of movies and films we watch, and some of these platforms make data available, with data agreements, so that you can analyze and answer questions about those types of trends as well. A large part of computational social science also focuses on social media interactions and connections, and understanding how ideas, memes, connections are made on social media. Other types of very large data sets that can be used in computational social science are also linked administrative health or other organizational data. So these would be things like tax records, health data. In a lot of Northern European countries, for instance, they have all of their administrative databases across kind of education and health, all kind of networked and connected. And so a lot of the innovations in computational science, social science, are coming out of Northern Europe, in part because researchers there have access to all of these kind of very finite, very fine grained data about entire populations, and not, almost the entire population if you're kind of recorded in the system. And there are some of these types of data that are available in Canada as well. They're the types of data that are often have to be kept private, that are housed in a private a secure data facility like the Stats Canada RDC or like our SEAL lab in Spark. And then a lot of computational social science uses any kind of large text, audio, or video corpus. And so this kind of trend in political science at least started with analyzing parliamentary debates, but now has gone on to analyzing people's voices and when they speak in parliament, and looking at the actual wave files and identifying and trying to identify when speech is sarcastic or argumentative, which is something that doesn't come from just the text necessarily. And increasingly we see as well image or video corpuses or corpi being analyzed. And some of these would again be how people gesture in certain types of social contexts where they've been videoed, like in Parliament. But I've also seen research, for instance, on social movements that shows that the news media, for instance, in one paper, they've shown that news media, when they're showing protests for Black Lives Matter, they're more often using images that are dark and taken at night. And when they're showing images of protests that happen around, say, environmentalism, they show images that take place during the daytime. And they do this all by kind of analyzing, using algorithms and automated methods, kind of the colors in the pixels of the photographs. And so they're able to take kind of large compilations of audio, text, or video and use these types of methods to identify trends in media coverage, in political speech, and social media, and the like. Was there a question? I'm happy to entertain questions if I say something provocative and you want to interrupt.
Well, honestly, like I find this like area so fascinating, right? Because like, I don't know, when you look at anything and the amount of information we've been gathering for like the last decade and a half on, let's say, Apple Watches, right? Like that, like small segment. And truthfully, like, okay, so the organizations we run is virtual healthcare. And I believe that virtual healthcare is like the next step with where we're heading, right? This is why, huge corporations like TELUS and that are pining for government contracts within this sector of like evolving sciences. And if we don't have social sciences up to par with this, we're not going to get there. And I, by far, am not tech savvy all over the place. It's just, I feel like as we progress forward, especially with the future generations and where they are and how we're digitizing everything, that is the next plateau in care. So what does that look like? And how do we get that information out when it's so big? I hear about them developing AI to extrapolate this data from huge big data networks when you hear about, these huge buildings housing servers collecting this information, right? So I am curious to see what that looks like. Even within the projects I'm doing now with the National Overdose Response Service, we're using simple ones such as like TalkRoute and Band. But if you were going to extrapolate information from that about the work we do, it takes a lot of construction of systems. That. So yeah, and I'm doing that in conjunction with the University of Calgary. And I'm curious to see what they come up with to make that work. And how does ethics keep up with that? Because we know, historically speaking, ethics is always like so far behind when it comes to like data, right? Like how do you take that to an ethics board? Will they understand? Do we need scientists on these ethics boards now to make sure that we're ethically working in practice? Or are we going to run into the same issues we did in the early social sciences with like really inhumane and privacy?
No, you have scooped some of my talk, which is great, but you have also raised one of my favorite talking points about these issues, is that a lot of this work, because it originated in the natural sciences and not the social sciences, and is done by engineers and computer scientists and mathematicians and physicists, they don't have the social theory and the social understanding. And so there have been important and grievous missteps in the application of these methods. And really, to do these methods well, it's hard for any one social scientist or computer scientist to know all the kind of social theory context and all the methods. And I personally, kind of the very first thing you said, that we need social scientists at the table who kind of understand the people and the behavior and the systemic biases that exist in our structures to kind of make sure that we're doing all of this work in a way that is informed by social theories and ethical. And so I agree with you on that. And it's I think really imperative on the social scientists to kind of insert ourselves in this work and kind of some of us that are kind of so inclined to become more trained in these methods so that we can sit at the table, because it's really hard to critique and engage the work if you don't know at least enough. And so I can talk a little bit more about why these types of things happen and where the interventions can come. And so part of it comes from this kind of the idea of machine learning or artificial intelligence. And the general way that this happens, kind of very, very kind of simplified, oversimplified, is that you take an existing data set and you train a model on that data set. You kind of walk barefoot through the data and find out what the patterns are. And then what computer science or computational social science used to do, kind of without thinking much about it, would use it to classify or predict future outcomes and behavior. And this is where these types of methods have been criticized for reproducing systemic biases and racism and structural inequalities. Because if you're going to tell police where to go, which neighborhoods to go to kind of police crime based on where crimes happened in the past, it's going to only reproduce certain types of patterns. A second type of analysis that's very common in computational social science is looking at networks and mapping connections and patterns of behavior between nodes, where nodes are either people or organizations that interact with each other, and kind of figuring out how ideas, how certain types of resources flow through networks in certain ways. And then the third kind of big bucket of methods has to do with these automated text, audio, or video or image analyses, where again, these methods often use the same type of process where you kind of train a model on part of your data, and then you use that to try to see how you can classify a larger set of data. And again, those classifications are going to be informed by what came before, unless the researcher intervenes. And so this kind of leads to the nature of these methods lead to some tensions with traditional quantitative social science assumptions and methodologies. So in kind of the kind of other types of quantitative methods I talked about a little bit earlier, the ones that are more common and have a longer history in the social science, tend to really emphasize the role of kind of coming up with a good theory, coming up with a good hypothesis, and then matching that to the data. Whereas the general approach in computational social science is very different. It's very empirically driven by kind of letting the data tell us a story, as opposed to coming up with a story and then seeing if the data match that. And there's also a tension around explanation versus prediction. You can have a computational model that is very accurate at predicting where something is going to happen or how, when something is going to happen, but that doesn't necessarily tell you why it's going to happen. And so it's often that slippage between kind of accurate predictions versus stepping back and saying, but do we really understand why this pattern is happening, that causes some tension within the social sciences. And so this has kind of raised this whole new area of research around ethical AI and asking questions like, are algorithms fair? Or do they reproduce, because of the nature of the method itself, do they reproduce structural inequalities, racism, sexism, otherisms? And there's also in trends where we're also asking the question of, is it ethical, or is AI ethical if there are like profound environmental consequences of crunching so much data, right? That like these server farms are very warm. They use a lot of energy. Should we be really kind of running such large models, kind of without having a very good justification for doing so? And so one of the things that we'll be doing at Spark, We're still confirming the dates, but we have talked and confirmed that 3 members of Google's ethical AI team want to come and do a virtual workshop with us sometime later this fall to kind of talk about some of the issues in ethical AI and what are the research frontiers, and really help us understand kind of how we can, if we're going to do this type of work, how can we make sure that we're intervening in ways to correct some of the biases. So if you're interested in kind of like learning more about these things, at McMaster, there's not a lot of options. I think, economics has a course that's limited to their PhD students. You might be able to find other options in other faculties. And so I've listed some of them here that I know have at least faculty members that are working in this area. And then the Mac Data Institute, they have a doctoral fellowship program where they provide a semester of funding for doctoral students who have identified kind of a faculty member in one faculty, like say the social sciences or humanities, and a faculty member in the science or engineering faculty who are willing to work together on a project with the doctoral student to produce a publication. And so if you're a doctoral student in particular, or a faculty member who's interested in this space, and you're, interested in working in this area, it might be worth looking at this doctoral fellowship program. And then of course, Spark, we're happy to try to help you identify who it is maybe is on campus that's interested in working in these questions, to try to kind of match make a pairing that you would be interested in. I know I had a faculty member from linguistics come to me and I said, hey, this is a great project, a great question, but I've actually got another colleague that would be a better match for you, and pass that on. And so that's another opportunity, particularly if you're a faculty or a graduate student. Again, if you're a doctoral student and you want to take more advanced training, that might be offered at other Ontario universities. And then for now, because the challenges of departments and entire faculties putting on these types of programs in Canada in particular, because we don't yet have a lot of expertise in this area, the easiest or the most expeditious way to get this access to this type of training would be through any number of summer schools. So at the University of Michigan, there's a very old program there called the ICPSR Summer Program. Disclaimer, I teach in it, not computational stuff, but they have added a number of computational courses over the last few years. And McMaster is a member of the ICPSR, so anyone affiliated gets reduced tuition to their summer program. And they do have kind of month-long summer program courses, but they do tend to have other courses that are 3 to 5 days and are not only in Michigan. Sometimes they're in very lovely places like North Carolina or out on the West Coast. So that's an option. In the UK, the Essex Summer School in Social Science Data Analysis also does a series of summer courses every summer that include computational social science elements. There is another organization that has developed a set of summer institutes in computational social science. I've put if you just kind of Google that, you will find them. And they also host kind of summer institutes focused primarily on computational social science at various different universities, largely throughout the United States, but I think there are a couple of others in Europe as well. I would also say if you're interested in kind of these issues generally and want to get a better sense of them, you're lucky because Nature put out a special issue this summer on computational social science. And so they brought together a number of the leaders in this emerging field, and they have lots of different articles that talk about ethical concerns, that talk about kind of the tensions between prediction and explanation. So all of these types of things that I've kind of just barely introduced you to, you can find a greater depth of discussion there and kind of future avenues. And so if you ever have questions about these types of opportunities or anything I've talked about, feel free to get in touch with us, and we can either kind of try to help connect you to other people on campus that are doing this work, or if we identify and can find a sufficient number of people that raise their hand and say, yes, I would like to attend a week-long or a 3-day or a 5-day training in a certain set of computational methods, as long as we have a minimum number of people that kind of indicate a willingness and an interest, we can look at the options for figuring out how to invite an expert to come put on one of these types of events.